Welcome to Climbing the Immune Ladder Steps for Success in Science, IISIAR podcast, the show where we explore inspiring experiences in science and the untold stories shaping our community. Today, we will be your hosts. I am Salma, postdoctoral fellow at the University of Montreal in Canada, and
I am Priya Goswami, PhD student in the University of Haifa, Israel, and where we work to understand the molecular pathways involved in the resolution of inflammation.
In each episode, we will dive into conversations with experts on innate immunity and sterile inflammation, autoimmunity, and their resolution, to bring you insights, ideas, and inspiration you will not hear anywhere else. Whether you're tuning in during your morning coffee or in your evening walk, get ready to learn, laugh, and see the world from a new perspective. Let's get started. Today's expert is Adrian Liston, professor from the University of Cambridge. Thanks for joining us and welcome to our podcast.
Thank you very much. It's a pleasure to be here.
Could you please tell us more about your research line?
Yes, I work largely on regulatory T cells. These are the key suppressive cell type of the immune system. So while most of the immune system is involved in activating immunity and clearing out infections, the regulatory T cells, they do the opposite. They're involved in shutting down the immune system and quenching immune reactions. And in particular, I work on how these regulatory T cells can get into tissues and adapt to local environments such as the brain, and how they can be used to control inflammatory disease or injury in those tissues.
Let's begin by going back to the start of your journey. Every scientist has a unique story behind why they chose this path, and we would love to hear yours. Can you walk us through your journey into the science? What drew you to the field of immunology?
Well, I think immunology is really an amazing area. I think it's the most interesting part of biomedical science because it touches on essentially every aspect of physiology. As an immunologist, I've been able to run projects in genetics, endocrinology, neuroscience, computational biology, developmental biology, and more. So, the great thing about working in immunology is that we can really pursue questions across the body and across multiple different systems. And I think that's something that's really special.
And did you ever have any pivotal moment that shaped your journey, either planned or not?
Well, I think we constantly have moments that shape our journey. Every time someone joins my lab, that's going to be shaping the journey of the whole lab and the journey of our research plans. For me, one of my first key moments was actually when I was doing a graduate assignment to develop a mock grant proposal. So, up until then, I'd planned to move into virology for my PhD. But during my grant proposal, the mock assignment that I had to do, I chose the area of immune tolerance, and I developed up a grant proposal to answer a question on immune tolerance that I found really interesting. And just as I finished my mock proposal, a paper came out by Chris Goodnow that essentially did the project that I had proposed and had just published it. And I emailed Chris about this and said, I found this an amazing project, an amazing paper that he's done, and I'd just written up a proposal to do the same thing. And after a half an hour chat, he offered me a PhD position. And it was really as simple as that. I changed the course of my career based on that proposal and a half an hour phone call.
That's interesting. Okay, so beyond scientific curiosity, is there any personal motivation or the life experience that deepened your commitment to studying immunology?
Yes, I think multiple times my personal experiences have impacted the direction of our research. For example, one of our main focuses in the lab at the moment is to develop a treatment for traumatic brain injury. And this was a problem that I'd never thought about before. And it wasn't until 15 years ago, when my brother died of a traumatic brain injury, that I started reading up about the immunology of traumatic brain injuries. I saw how dramatically under researched brain injury is as a field, considering just how incredibly common it is. Half of all people are going to get a brain injury over their lifetime, and yet there's very little research that's done. And I realized that I had the training to make a difference. So we pivoted part of our lab into working on traumatic brain injury and trying to develop treatments for that.
Thank you for sharing this with us. And you've been telling us about different projects you've developed throughout your career. Could you highlight a key discovery or project you're the most proud of and how that impacted the field?
Yes, I think this continues on from that work on traumatic brain injury. One of the things that I was really fascinated about is the possibility that regulatory T cells that dampen down inflammation could be harnessed in the context of a traumatic brain injury. So we developed a transgenic mouse strain where we could have more regulatory T cells in the brain. And if we developed that and we had more regulatory T cells in the brain, when that brain of the mouse was injured, it became much more resilient to injury and it had faster repair. And then we took that basic knowledge about transgenic mouse strains and we developed a gene delivery technology that we're now trying to get into the clinic and test in humans. So it's something that I'm really proud of because it's gone the whole way from understanding the basic biology to applying it in a injury setting. And now we're trying to get it into patients. And that would be an amazing outcome.
Definitely. Always seeing the impact in a patient is the best. Yes.
So, what's your process for identifying high impact research questions that are worth investing your time and resources in?
Well, I think the first thing is it has to be something that I personally find interesting. We spend a lot of our life on the research questions. And so rather than trying to research purely for others, I try to research questions that I find fascinating. Now, fortunately, immunology is such a target rich field, so there's really no shortage of questions. There's any number of things that we can look at that haven't been done before, that are interesting biological questions, and that will also have impact on patients and on the field. Once I've got one of those questions, and like I said, it's very target rich, so you can just pick up many questions and have a look at them. I then think about what technology is available. Is there technology that is available right now that can formally answer the question? Or is there tech that's within striking range to develop that maybe we can put a couple of years of tech development in and then have the right technology to answer the question? And I'm really keen on only approaching questions that I can formally answer. I don't want to have inconclusive and correlative evidence. I really want to be able to dive into a problem that we can formally find the answer to.
And as we have many questions and many techniques, we also have a lot of challenges in science. Which strategies help you to push through the toughest scientific challenges throughout your career?
I'm not sure that I do push through the toughest scientific challenges. I'm not someone who has a single focus. And so, if a given problem ends up being substantially harder than anticipated, I tend to give up. I tend to pivot to a related problem that is ready to be addressed. I move on and use the tools and the knowledge we have to answer a question that has got some lower hanging fruit. Now, I really respect people that get one problem and will solve that problem no matter how hard it is. But for me, my approach is actually to be more versatile and to pivot away from problems that look too difficult and hit one of those problems that is just ready to be solved.
That's a quite interesting approach, actually.
If we talk about decision making and opportunities, two things that can truly shape a scientific career. Can you share with us any crucial decision or opportunity you had that significantly advanced your career?
Yes, I think probably the single best decision I made would have been the first person that I hired for my lab. At that point, I was quite a junior PI. Didn't have a whole lot of experience. And the first person that I hired was a senior lab manager who had been in science for a decade longer than me. And James, who I hired at that point as a technician in the lab, he had so much experience at the nuts and bolts of running a lab, the logistics side of it, getting things up and running, ordering equipment, having the processes involved that go beyond simply coming up with an idea and actually turn it into an executed idea. And having someone with those skill sets already in place, that allowed me to specialize in the scientific questions, allowed me to specialize in writing grants and writing papers and specialize in later on in developing and mentoring my team. So I think that that division of labor between me and James really allowed me to flourish in a way that I couldn't have if I was trying to do the job entirely by myself. Now, actually, we're still working together nearly 20 years later, and the relationship has changed. We're now co PIs, we're both professors in the laboratory, but we still have this division of labor in terms of the functions that we have in the lab. So I think really it is too big a job for one person to do by themselves.
Definitely, PIs are always busy. How do you evaluate and assess new opportunities while managing existing commitments?
Not very well. Historically, I have said yes to too many things, and then I start saying no. So I tend to go through boom bust cycles of overcommitment, and then all the no's start catching up, and I've got a period that I can relax again. And I'm happy enough with that. It's probably not the most organized approach, but I think it's what works for me.
Everyone has their own approach, definitely.
Sometimes what feels uncertain at first can become the best decision. Looking back, were there any career moves you initially doubted that turned out to be the right choice?
Yes, I think so. I became a PI at a very young age. I was 28 at the time. And basically, I didn't want to be a postdoc anymore. So I started looking for faculty positions really earlier than I should have, earlier than I was ready for. And I was very fortunate in being able to get a faculty position, but it did limit my choices. Now, I talked to some universities and some departments that I was really quite keen to join. And the answer was, you're on the right track, but come back in 5 years after another postdoc, and then we'll be very interested in talking to you further. For me, though, it was the right time to start up a lab. And I ended up going into Belgium and joining an institute called the VIB. And that at the time was really an emerging research hub rather than a hub that was already elite and expert rich. I think that ended up being a huge benefit to me. I think it was actually a very positive thing for me to go into a institute, go into a research environment that was still in that stage of investing and growing talent. They didn't have an expert on every single topic. So I could really branch out and start up collaborations on things that were quite tangential to my original expertise. So I think that allowed me to broaden my horizons, allowed me to develop new interests and to grow in a way that I think I wouldn't have been able to grow if I started up in an institute that already had 100 immunologists, each of which had to be pigeonholed into a narrow area of expertise.
Definitely. And what non-scientific skills have been the most critical to your career progression? And how would you advise that we can develop these skills?
I think the most critical thing has been learning to support my team. This is something that I always wanted to do, but it wasn't something that I was always able to do. I think we get a little bit confused by, say, the golden rule. Treat other people how you want to be treated yourself. That's not a bad starting point, but it only really works if you've got a lab of mini me's where everyone wants to be treated the way you want to be treated. And actually, people are all unique. People have different motivations, they have different drives, they have different ambitions, they have different emotional scar tissue left over from previous experiences. And I think what we really need to do is learn to treat people how they want to be treated. So we have to learn a lot about our team members. We have to learn what their drivers are. We have to be able to interpret their body language, interpret what they're not telling us so that we can respond better to their unspoken needs. That's a tough ask. And it's something that I wasn't naturally good at. It took me time to learn, and I'm still trying to learn on it. But there are ways you can do this. You can talk to people, you can read books. I, for example, quite like the Gottman Institute books on relationships. And then when you fail, you can learn from your failures and practice some more.
If we see science, it really moves fast and staying relevant can be challenged. What habits or strategies do you rely on to stay current with scientific advancement and continuously foster your professional growth?
Well, I don't think anyone can completely keep current with scientific advancement. The progress of science is ridiculously fast and it's escalating at a rate which means that you'll never be able to read all of the papers in your field. And I certainly don't. I don't even come close to it. I prefer instead to try not to work on a crowded question. I don't want to work in an area where I have to be anxious about every paper that comes out and have they scooped us, partly because I don't need the anxiety, and partly because I wouldn't feel like I was making a difference if I knew that someone else was going to be solving that question in 6 months, whether I did my work or not. So I try to be a bit more sanguine about this, not worry so much about all of the scientific advancements happening around me. Just try to appreciate the growth in technology, appreciate new concepts when I come across new concepts by talking to people, and let my research go at its own speed. Right now, I'd say a lot of my personal growth is not so much coming from scientific expertise, but rather from my activities in research culture and career mentoring. This is something that I'm putting a lot of focus into at the moment. I go and give advice and workshops to students and postdocs about their career and improving research culture. And I grow by listening to them and listening to their challenges and their experiences. And it allows me to improve my practices and it allows me to improve the advice that I can give to others.
And talking about this mentorship, what advice do you have for finding an effective mentor?
It's a good question. I think one of the most important things is to understand what it is to be a mentee. So you don't necessarily have to have one good mentor. You can have people who are going to mentor you for one problem once in your life, and then you don't have to have a further interaction with them if they've left an impact on you. So, the more important thing, I think, rather than finding that right person, is knowing how to approach a mentorship conversation when the opportunity arises. I think one thing that people tend to forget is that being a mentee is not about going up to the altar of wisdom and having it imparted upon you. It is about thinking in advance, what is the question that I actually want to solve? And sometimes that can be difficult because we focus on proxy problems rather than the deeper problem. But if you spend that time thinking in advance about what the deep rooted problem is, what are the parameters of a solution that would be acceptable to you, and then you lay that out in advance to a mentor before you're having a conversation so that they can consider where you're coming from, then you're going to get advice that is more directed to your problem and that is going to be more reasonably adapted to your situation. So I think that investment in learning how to be a good mentee allows you to make the most of mentorship situations when they arise.
Definitely. And what skills do you feel are often overlooked yet essential for success, both in science overall and specifically in immunology?
Well, it's not specifically immunology, but I think the answer is kindness. Scientists are really overtrained in criticism. This is important for our field. We have to self doubt. We have to try to destroy our hypotheses. We're trying to prove ourselves wrong all of the time. So that is a key skill for us is to criticize. However, we're so overtrained in it, we can forget how to be kind. And in particular, we can forget the impact that relentless criticism has on other people. In particular, new researchers to the field, new scientists who haven't yet experienced criticism after criticism. So I think it's important for us to train ourselves not just in the criticism, but in the kindness that balances that out when you deal with other people.
Definitely. We all get advice along the way, but sometimes one line really gets stick. What's the most valuable piece of career advice you have ever received?
Can I give two pieces?
Of course, yeah.
Okay, at a junior stage, I think the most valuable piece of advice I got was to join a lab that has a record in the type of achievement that I want to have. If I want to get a top paper, go to a lab that's got a record of getting top papers. If I want to become a independent researcher, go to a lab that's got a record of people leaving there to become an independent researcher. If I want to be successful as an entrepreneur, go to a lab that has a record of getting patents and getting spin off companies. If I want to be in an environment that is a positive environment to be in, go to a lab that's got a record of people coming out of that lab saying what a positive environment it is. I think that is really a key thing for us to look at, understand what it is that we want to get out of a lab, and then look at labs that have got a record of achieving that. Now, the other piece of advice that I got at a senior stage is when negotiating an startup package, when negotiating a position, always get it in writing. You really need to have something in writing because ultimately you're making an agreement with an institute, not a person. The person you make the agreement with might be gone in 6 months. They might be moved on to another position. And if you don't have the terms of your position and the terms of your employment and your startup package, if you don't have that in writing, then essentially you don't have anything.
And what unique or personal advice would you give to someone that is just starting in our field?
I'd say if you're starting up your own lab, my advice would be to first invest in developing the research culture. I know it's a common idea to, first of all, get the experiments up and running, get the lab productive, and then you can focus on things like research culture and you can focus on people afterwards. But first, we just need to get data flowing. The problem is, if you take that approach, it's kind of like pushing a boulder up a hill. You have to push and push, you're constantly struggling, and the minute you stop, you're going to get crushed by your own boulder. On the other hand, if you focused first on the culture, make sure you've got an environment where people help each other and support each other, an environment where good ideas come from all over rather than just from you. It turns out that starting a good project is like pushing a boulder down a hill. It gathers its own steam. It can keep on going without you. And it's a much more positive environment and ultimately a more productive environment to work in.
If we talk about something that often gets overlooked in science, life outside the lab, balancing intense research, deadlines, and personal well being isn't easy, especially in high profile careers. So, we would love to hear how do you navigate the demand of a scientific career while maintaining a healthy work life balance?
It's a difficult one because academia is a greedy job. So, greedy jobs are jobs where there is no amount of work that you can do that all the work is done. It doesn't matter how many grants you write, you could always write another grant. It doesn't matter how successful the research is and how many questions you answer, there are always going to be new questions that you can ask and new questions to answer. Doesn't matter how good your teaching is, you can always improve your practice. You can always develop the curriculum more. And that is a problem because there's no end to the amount of work that you could do. And ultimately, people who have these jobs tend to really care about the job. They care about the questions they're asking, they care about the people they work with. So you've got a situation where the job could suck out infinite amounts of energy and you care about getting it wrong. And that is what really gives the anxiety. So you really need to be able to set the boundaries for yourself because work's never going to set the boundaries for you. No one's ever going to say, hey, fantastic job on that latest paper. Why don't you take the next couple of years and just dial back stuff and relax a bit more? It doesn't happen. People expect the next thing. You have to put that limitation on yourself. And ultimately, this means that your job is going to involve juggling many, many balls. And if you try to keep every one of those balls up in the air at the same time, you're going to drop balls. And I think it's important for us to understand that it's okay to drop balls as a PI. it's in fact inevitable to drop balls as a PI because there's just too many tasks for you to juggle. I think, though, that the key thing is to make sure you don't drop the big three. Don't drop issues about your team members' happiness, your team members' role in the lab. If something comes up that's important to your team, it has to be handled by you and it has to be handled successfully. Don't drop your big papers. Those are your outputs, those are your key scientific currency for your whole career. Those are the discoveries that we want out to be part of our legacy. And don't drop the grants. If you don't have grants, then that's going to cut off your ability to support your team. It's going to cut off your ability to do future research. So I think if you drop the occasional ball on the other fields, that's fine. It's probably a good sign that you're concentrating on the most important things: your team, your papers, and your grants.
Indeed, being a PI involves a lot of work. And have there been any sacrifices along your career path? And did you ever wish to have chosen differently?
Yes, I'd say maybe 3 times I've felt like quitting my job and leaving my lab and getting out of academia. All 3 times were due to bullying situations, which can really suck your enjoyment out of your job. And the job is hard enough that when you're not enjoying it, it doesn't seem to be purposeful. Now, that's not terrible over the course of 20 years, but at the time it did impact me a lot. And those times I did think about, maybe I've chosen the wrong career pathway. Now, I'm glad I've kept to my position. I'm glad I've kept where I'm going, but I'm still open to changing my career. And maybe I will, over the next 20 years, change my track and do something completely different.
Everything can be possible.
As you look ahead, what do you think are the biggest challenges and opportunities you see for the next generation of scientists?
I think probably the biggest challenge is career fragmentation. Now, when I say career fragmentation, what I mean is what people will often call job insecurity. And I don't really like the term job insecurity because it implies that you're at high risk having a job in biomedical research. And I think that's not actually the case. Biomedical researchers have incredible employment opportunities across large numbers of sectors. If you've got a PhD in biomedical science, you're probably always going to have available a great job. I don't know really any PhDs in biomedical science that haven't found a fulfilling job across one sector or another. But the problem is that the career is much more fragmented than it used to be. We used to be in a situation where you would get your post PhD job, or maybe a postdoc and then the post PhD job, and you'd know what you're going to be doing for the next 30 years. This was going to be your employer. You were going to be working in biotech, or you're going to be working in big pharma, or you were entering the public service and you're working in policy, or entering academia and you're going to be a professor. And you could reasonably expect that you would be going and staying with that one employer over the course of decades, and your job would grow with that employer. I think that's not the reality that people are going to be in now, and especially not for the upcoming generation of scientists. I think very few of us will have a single career. Instead, what we're going to have is a series of careers over multiple stages. So rather than have one 30-year career, you might have 6 5-year careers that will each build upon the other. They will give you this intertwined set of experiences that makes you more valuable, that makes you more versatile, that gives you multi sector experience. These are all things that positively drive your success, but they do add to the anxiety because you will have multiple points in your career where you're going to be changing sectors, where you're going to be changing employers. And even though in retrospect, you can think, actually, it wasn't that hard. And I did have multiple offers and I'm now in a better place than I was before. at the time, it will feel stressful. It will give you anxiety. And I think that we need to recognize those feelings when they come up. We need to try to give people the tools to deal with them, to try to give people the support they need to make those transition periods as short and as painless as possible. But it is a big challenge.
And what's your opinion of the emerging of new technologies as AI, for example?
Science rides technologies. Technologies come out, they allow us to ask new questions, and they allow us to make new discoveries. We are built on new technologies. So, to that extent, any new technology that comes on board is going to be a technology that allows us to do better science. There are always fears about a new technology. At the moment, people are worried about AI. 20 years ago, people were discussing the new robotic systems and were they going to replace benchwork scientists because you just had to program a robot and then everything would work for you. The reality is that we are changing as scientists. We are using these tools. It changes our practice. For every person who's not pipetting because of a pipetting robot, there's someone else who is programming the robot and making sure it's the most efficient. And of course, there are questions that are not well answered under that high throughput system that really need to have a scientist. Same is true for AI. There will be places where AI is useful. I think AlphaFold is a good example of that. But there are many, many more places where AI is not useful, where having the creativity of an actual trained expert is what's required to ask the right question. And then essentially, AI doesn't generate new data. AI integrates data. And we're not in a field where all the data is already available. We're in a field where we desperately need more data. So there's going to be a place generating data, generating questions, and putting those together for at least the lifetime of our youngest scientists right now. So I'm not worried about AI.
And I saw you have created children books and even a game to help kids understand science. So, what inspired you to communicate complex scientific ideas to children in this way?
That's simple, being a father. So my son is interested in what I do. He would always ask me about where I go to work and what I do at work. And so I try to tell him. And I think that we can always explain our work to children. It's just a matter of thinking about what is the language that is appropriate for them and what are the concepts that we want to communicate. And if you commit to talking to your children and having a discussion with them about what you do, you'll find that you become better and better at having those discussions. Then I started thinking about how I could make a difference in the vaccine debate. And I think one of the issues with vaccination at the moment is that there is a lot of bad faith arguments. A lot of the people who are anti vaccination, they're not misinformed. They are deliberately obscuring facts. And so, for my personal approach, I don't want to engage with those people. I am glad that there are people who challenge them and call them out on this. But for me, that was not going to be a positive part of my life to be having confrontation type discussions with people who are deliberately trying to confuse the public. And instead, I thought, well, how can I make a difference to this conversation with the skill sets that I've got and in a way that would be a positive to my life rather than be a negative. And so I decided instead I would try to help promote a positive narrative about vaccination, to start talking to children, or through my books, to start talking to the parents of children. So I'd write a book about a child with an immunodeficiency who is dependent on the vaccination of his friends in order for his own safety, and how that would be experienced by the child and how it would be experienced by the parent. Now, part of that is about teaching the child about the basics of vaccination, but part of it is also about the parent who's reading that book understanding the perspective of a parent of an immunodeficient child and how they must feel about the risks that their child faces every time they come in contact with an unvaccinated child. So, really, it was written as much for the parent as for the child.
We would we would love to hear a standout moment from your career. Something lighthearted, surprising, or out of the ordinary that you feel comfortable sharing with us.
When I see someone from my lab go on into a leadership role and I see them try to implement the same type of lead with kindness approach that I've ended up advocating, that to me is the most wonderful thing, because then it's not just that I'm having an impact on immunology through my research or even the research of people in my team, but actually we have an impact on the people who are trained by the people who were in our team. And that legacy just grows and snowballs the further you look at this. So I think this is really why caring about people and caring about their growth ends up being the most impactful thing you can do in science.
Yes.
Thank you very much for sharing this with us.
My pleasure.
That's a wrap for today's episode of Climbing the Immune Ladder Steps for Success in Science IISIR podcast. A huge thanks to our today's guest, Adrian Liston, for joining us and sharing his insights, stories, and experiences with us. We hope you found this conversation as inspiring and thought-provoking as we did. If you enjoyed the episode, don't forget to join us on the next episode and share it with anyone who might benefit from it. You can also follow us on our web page to stay updated on future episodes and also on innate immunity. Thank you for listening, and remember, persistence and asking the right questions are what drives science and maybe even your own journey. Until next time, stay curious.